So in this video, I'm going to begin to introduce you to the idea of chemical reactions. So all chemical reactions have two different parts. There are the reactants. These are the substances that you start with that go into the reaction. And then there are the products, and those are the substances that you end up with at the end. And when we write a chemical reaction, we're always going to put the reactants on the left-hand side and then use an arrow to indicate that the reactants somehow form this new set of products which are placed to the right-hand side. So just to give you a basic idea of a chemical reaction, we've done a lot of food labs, so baking is essentially a chemical reaction. So we have all of these reactants here, so salt, flour, sugar, water, yeast. And when we put all those reactants in and we apply some sort of heat, we then get a product, which is the bread. Now, during a chemical reaction, we know that atoms are not created nor destroyed. They are only going to change forms. So if you remember, this is the idea of the law of conservation of mass. So one of the first labs that we're going to do is to prove the law of conservation of mass and sort of show this, this happening. Okay? So when we put two things together, it is sort of the laws of nature that define whether or not a reaction is going to happen. And so when a reaction happens, we can describe that reaction in terms of a sentence where we say every item as a word. So we can say, you know, copper reacts with chlorine to form copper 2 chloride. So this is a reaction that actually happens. Now, how we represent this in chemistry is we then take the sentence and we create a word equation, and then we actually create what is called a sentence or a skeletal equation, which uses our chemical formulas. So the word equation here using this sentence says that copper reacts with chlorine. So you know that copper and chlorine are the reactants. So those would be on the left-hand side, and we indicate them by putting a plus sign in between that there are multiple reactants. Then they come together and they form copper chloride. So we draw an arrow, and then on the right-hand side we place what the product is, our copper 2 chloride. Okay, so the arrow that separates the two means yields or reacts to form, and the plus sign means an and. Now, we have learned some other symbols that can go into a chemical reaction. So, for example, the parentheses S. We learned when we wrote formulas that that means that the state of matter that the substance is, either the reactant or the product, is a solid. And this helps us to identify the reactant or the product when we're actually performing it in the lab. So in this case, if we had a small letter G, we knew that that product would be a gas. And so if we performed the reaction and we got a gas, we would know that that gas in particular would be, you know, carbon dioxide in this case. L means that it's a liquid. And then lastly, we have AQ. So AQ means that it's aqueous or dissolved in water. So we like to use these symbols as well when we write out the skeletal equation, which we'll look at next, in order so that we can know what we're sort of looking for in terms of reactants and products. So what we do is we take that word equation and we're going to then replace the words with our chemical formulas and symbols to demonstrate the reaction. Now, they are not balanced, which means they are not demonstrating the law of conservation of mass. That will come in a later video. Okay, but at least we can have a chemical equation generated that is a description of the reaction. So let's just look at an example here. So this is the sentence. It says, so solid iron 3 sulfide. So we know how to write the formula for this, and we are told that it's solid. So if I wanted to represent this as a reactant, I would put here. So we have to crisscross down and write our chemical formula, and then in parentheses I put as to indicate solid. Reacts with, so that would be a plus sign. gaseous hydrochloric acid. So hydrochloric acid would be HCl, and then I'd put in parentheses G. To form, so that is the arrow, iron 3 chloride, and in this case it doesn't tell us if it's a solid or a liquid, so we don't have to put in any indicator of that, and hydrosulfuric acid gas. So H2S for hydrosulfuric acid, and then G for the gas. So we can see that these are the reactants and these are the products. Now I just want you to note that what products are formed is a result of the laws of chemistry. So not always are we going to form reactants. We're not always going to have a reaction when we put two things together. But always the products that are formed will be things that actually exist, and we need to pay special attention to the formula writing, because we know how compounds combine and how elements combine to form compounds, and so we have to be sure that we're following our formula writing rules when we are writing either reactants or products. All right, let's do one more. So you have nitric acid dissolved. So nitric acid is HNO3 and it's dissolved in water. So that would be aqueous. Reacts with, so that's the plus, solid sodium carbonate, so that's Na2CO3, carbonate's a -2, sodium's a +1, with the solid, to form aqueous carbonic acid. So carbonic acid is H2CO3, the AQ for aqueous, and then sodium nitrate dissolved in water. So sodium nitrate is NaNO3, and that is aqueous as well. Now we can go backwards as well, so we can be given the chemical equation and then we can also describe it using words. So for example, here we would say solid iron reacts with gaseous oxygen to form solid iron 3 oxide. Or we could say here, solid copper reacts with aqueous silver nitrate, or we could say dissolved in water, silver nitrate dissolved in water, to form silver, so solid silver, and aqueous copper, and that would be copper 2 nitrate. So again, we just get the general idea of the reactants, the products, and how to write a basic chemical equation. And in the next video, I'll start to talk about how and why chemical reactions happen.